Hello and welcome to today's video where we're going to talk about the sector area of circles. So this is really similar to the arc length section that we talked about. So sector area is the area enclosed by an arc and two radii to its endpoints. So if we have our circle right here, the sector area is the area of this whole thing. So it's the area of that little triangle cutout, and because it's the area enclosed by two radii. So this is a radii here, let's name this point C. AC is a radii and BC is a radii. So that just means they're two radiuses meeting in the center of the circle and forming an arc. So it's different from arc measure, which is the degree size of the central angle. So it's not 45 degrees because now we want the area. We want the sector area, not the measurement. So it is very similar to arc length. It's kind of like the idea of perimeter versus area. So when we were doing arc length, we were finding the length of this arc. So that's kind of like the perimeter of the arc, whereas now we want the area of the arc. So the formulas are really similar. So remember that the length of arc AB was measure of angle AB divided by 360 times 2 pi r, where we had this formula because that was circumference. So we're multiplying the length of our specific angle divided by the entire circle, which was 360, and multiplying by the circumference. Well, now what we're going to do is we're going to take the length of our angle divided by 360, and now we're going to multiply by the area formula. So this is the area formula. This is kind of the portion that our arc makes compared to the entire circle. So again, it's really intuitive. And let's look at this example here. So measure of angle AB divided by 360. So we're looking for the area of AB. So area of AB. Well, it's going to be the measure of arc AB, which we're given the central angle measurement is 45 degrees. So 45 divided by 360 times, and now I'm going to multiply by the area, and that's pi r squared, and r is 6, so I get 36 pi. And I'll get 1, so this is 1 divided by 8, so 1 divided by 8 times 36. I can just rewrite times 36 pi, I should say. I can rewrite this as 36 pi divided by 8. Then simplifying that, I can divide everything by 4, and I will get 9 pi divided by 2. And that's the area of our arc. So again, it's really similar to the arc length formula. If you have that down, you should be able to get this one pretty simply. And so the only difference is that instead of multiplying by the circumference, we're multiplying by the area of the entire circle. So let's get into some examples. Alright, so example 1, given that the area of the circle is 81 pi units and the measure of angle CD, or arc CD, is 120 degrees, find the area of arc CD. Okay, so I'm going to label these CD because that's obviously what we're talking about here. And I want the area of arc CD, so that's going to be this area right here all the way inside. That's what I'm looking for. And I'm just going to write down my formula. So I know the arc area, so CD equals, well, I know it's the angle measurement divided by 360 times the area, right? Well, I'm given the area, so this is actually pretty simple. So I'm just going to do 120 over 360 times 81 pi, and that'll give me my result. So 120 over 360 is 1/3 times 81 pi. I keep forgetting the pi, so it's 81 pi divided by 3. And that can be simplified. 81 divided by 3 is 27, so I will get 27 pi. And that makes sense because what I've done is the entire circle has a area, so this whole thing, its area is 81 pi, and I'm just taking 1/3 of it. I'm looking at 1/3 of its area, so it's got to be 27 pi because that's 1/3 of the 81. So that's why that kind of makes sense intuitively. Alright, so let's look at one more example of sector area. So now it says that the area of the arc FH is 25 pi and the diameter of the circle is 20. Find arc measure of FH, or measure of arc. Yeah, so I'm going to start with our area formula because that's what we're given here. We're given the area of the arc is 25 pi. So I'm going to write, sector area, so I'll just write area of arc. So FH equals, I know it's the measurement, so measurement of FH divided by 360 times, and then I multiplied times the area, which is pi r squared. Okay, and now I'm going to plug in everything I know. So I actually know the area, so area of, I'll just write that here. Area of FH I know is 25 pi. And now I know that that has to equal, well, the measure of angle FH, which is what I don't know, divided by 360 degrees, times pi r squared. Now I'm not given r directly, but I have an easy way to figure out r. Remember what a diameter is. A diameter is the length from one end of a circle all the way to the other. So that's 2 times the radius because it's got to go through the middle halfway. So that's 2r. So d equals 2r. This is an important thing to remember. So diameter equals 2 times the radius. So now I'm going to get, well, 20 equals 2r. So r must be 10. Okay, so now I'm going to get 100 pi because that's just 10 squared times pi. And now I'm just doing an algebra problem. So now I'm going to solve this equation here. Let's just put it right here. So I'm going to divide by 100 pi first. Divide both sides by that. And what's 100 pi divided by 25 pi? Well, the pi's will cancel and I'll get 1/4 equals measure of FH divided by 360. Multiply both sides by that 360. What's 1/4 times 360? That's 360 divided by 4, which can be simplified to 90 degrees equals measure of FH. So now let's actually draw what we have. So we know a 90-degree angle looks like this, just a right angle. So going to the center, then going directly to a side. And I'm saying FH, so this would be F, this could be H. I'm saying that that is 90 degrees there, so this is 90. And what I'm saying is that the area, or what I'm given, is that this area in here is 25 pi. That is the sector area. So hopefully this makes sense. Hopefully this is a good introduction to what sector area is, how it relates to arc length, and just arc measure in general. And I hope you really get the intuition behind it. And in the next video, we're going to have some practice going back and forth between arc length and sector area. So you're really going to have to know the two formulas and when to use which one. So thanks for watching, and let me know if you have any questions.